So now moving on to Chapter 12C, Index Laws. The green box on the first page are the summary of all the 7 index laws that we'll be using this chapter. As you can see on the right side, we have a PDF. Now this PDF, if you open it up on your OneNote, you will see that it has a PDF of explanation of how each rule have come out to be, how this is the proof of each law, so we understand why such law exists. I strongly encourage you to take your time to read over this and write it in your book so that these laws are not something that you try to memorize, but something that you understand. Because once you understand it, there's no need to memorize it anymore, and therefore in the test you'll be able to apply it very quickly and successfully. However, for the purpose of this activity, we will move on and the proof will be read at your own time. We will start by doing the questions. These questions on the left from question 1, 3, 5 on the left column are the ones that I would like you to do. The one on the right column in the red are the demonstrations that I will go through in this video. After you hear my demonstration, I'm going to ask you to stop the video and then complete the following 6 questions on the left column. So let's start. The first demonstration, factorization. Now, some of us may already know how to do factorization, but I thought I'll demonstrate how to factorize big numbers in a way that will be helpful for this chapter. For example, there's a question such as convert 729 into the power of 3. So it asks us, what is n as an indices that's a power of 3 that makes it 729. Now 729 is not a number that we just memorize what 3 of power is equal to. So we have to actually do factorization in order to get this. And how I do this is as following. And this works also for just finding the factors for big numbers. I first start by writing 729, the number that I would like to factorize, the big number. And I essentially do the long division, but it's reversed, it's flipped. Instead of doing long division that you would have seen like this, I do it like this. And then what I do is I think of a small prime number that I could think of. A good example is 2 or 3 or 5. If a big number is an even number, I immediately start with a 2 because even number gets divided by 2. However, for this one, it is an odd number, and also the question did give us a hint that it has to be base of 3, which means 3 times 3 times 3 times multiple times n times makes this a 729, which means 3 has to be its factor. So I'm going to divide it by 3. If I divide it by 3, it becomes 243. You could use a calculator or you could just do it in your head. Now, once I have 243, I'm going to do it again, another long division sign, and then on the left column, I'm going to write down 3 again. Why 3? Because we know it's multiples of 3. 243 divided by 3 is 81. And then I just continue this process. 27, 9, 3, and 3. Now we can't go any further because if I go 3, it just becomes 1. I could do that, but there's no point. When I reach a prime number at the end, prime number, or I'm done. And now what I do is I count the number of 3s that divided 429. So we have 1, 2, 3, 4, 5, 6. So therefore, 3 times 3 times 3 times 3 times 3 times 3 is 729. Therefore, 729 is 3 to the power of 6, making n equals 6. This is factorization, and this could work for other numbers as well. Now, I would like you to pause the video here. I would like you to try question 1, 3, 5. using the index laws of the green boxes and trying out. Pause the video now. Good luck. Now that you've finished the questions and you have resumed the video, I'll move on to the next part. The next demonstration is writing without negative indices. Now, using the index law number 7, and number 7 means the 7th one from the top, which is any number base a to the power of negative n is equal to 1 over a to the power of positive n. Now, once again, the proof of this is in the PDF file. Now, how do we use this in order to convert this fraction with negative indices to not have any negative indices is the demonstration that I'll be going through. If we have a look, I have written down the question 2a to the power of 1 all over d to the power of negative 2. The first line I'm going to do is I'm going to divide it into parts. So I've divided this into 3 parts. 2 times a to the power of negative 1 times 1 over d to the power of negative 2. And then I have converted the negative indices to positive indices. And I can do that by using the law, index law. And when I did that, I get this line of 2 times 1 over a times 1 over d squared. Now, 2 and 1 over a remains the same, and I just simplify the third one to be d over d to the power of 2. Now, how does this work? If you have a look at the right, I have shown how I got that. So, when we have a fraction divided by a fraction, like an a over b as a numerator and c of d as a denominator, this is the insides becomes the denominator and the outsides become the numerator. This is a neat trick to know for doing fraction simplification. So for that reason, I get d to the power of 2. And lastly, I now bring this all together. It becomes d 2d squared all over a. So now the form has changed. However, it is still the same number, and the indices have become all positive, which is what the question have asked to do. So I have answer of 2d over a. Now I would like you to pause the video and then try up to question 7 and question 8. Good luck. Now that you've resumed the video, now I'll move on to the last demonstration. The last 2 demonstrations I will do is writing in non-fraction form and also reminding us what a rational form is. The question will ask you, write the following in a non-fraction format. What it's asking us to do is when we have a fraction format question given to us, you have to convert it so that we only have one base and then indices. That is not in a fraction form, just like it is shown. So how do we do that? Now let's have a look with an example. If you have a look at example 7x negative 4 over x plus 5 over x squared, what I'll do is I will make sure by using the law number 7 again, 7x remains the same because it's not in a fraction. I want to change these 2 fractions that we have. Now negative, this is 4 times 1 over x plus this is 5 times 1 over x squared. Therefore, this is 4x negative 1 plus 5 x to the negative 2 using law number 7 once again. Therefore, now we no longer have fractions in the answer format, which is what you've been asked to do. Lastly, there are questions where it asks you to write the answer in a rational form. Simplest rational form. And just to remind us what a rational form is, a rational number is a number that can be denoted in a fraction form, with numerator and denominator a, b being an integer. An integer, once again, a reminder, is a whole number, positive and negative numbers, whole numbers, including 0. So -3, -2, 0, 1, 2, 3, and so on. And reminder that the denominator b cannot be 0 because nothing can be divided by 0. I would now like you to pause the video and attempt question 9 all the way to question 12. Good luck.